Hi everybody, and welcome to Notes 3.3. Today we are going to be talking about graphs and attributes of absolute value functions. So, if you remember back to day 3.1, we introduced all 6 of the parent functions. One of these functions was the absolute value. So we have f of x equals the absolute value of x. If you'll recall, we also came up with the parent function table where the x's were the fab 5, negative 2 to 2, and then we found the y values that corresponded to each x. Please remember that absolute value is the distance from 0, therefore all of our y's are non-negative numbers. So we graph the 5 points from the parent function table, and then we play a fancy game of connect the dots. We also discussed the domain and range in interval notation. If you remember, our domain was negative infinity to infinity. However, our range was 0 to infinity, where 0 gets a bracket. And that is because our lowest value on the absolute value parent function is 0 for the y's. So the lowest value is 0, and the highest value, it just keeps going to positive infinity. And the reason we use a bracket on the zeros is because we can actually touch that point on the graph. Let's find the x and y intercept. Well, we know that the parent function intersects the origin. So the x-intercept and y-intercept are both 0, 0. Now let's focus our attention on finding the max and min over a closed given interval. Now, this is not going to be as straightforward as it was when we were doing max and min of a linear function, and this is why. The absolute value has a vertex, okay? So we have to check to see, is that vertex inside the interval? If it is, then we have to consider it when calculating the maximum and minimum over our interval. If it's not, then we don't have to, but we do have to at first consider it. So what I want y'all to get used to is I want y'all to get used to from absolute value on using this notation. F of L, F of H, and F of R. F of L, F of H, and F of R. Now we know left and right, the L and the R, we know that comes from the closed interval. That comes from the closed interval. But what is this H value that we speak of? Well, and we'll learn more about this in the upcoming slides, H represents the x coordinate of the vertex. So since it's the x coordinate of the vertex, I can pull that off my table or I can pull it off my chart. You're going to see that we can eventually take it out of the equation. So I look and I say, well, okay, my vertex is 0, 0. So if H is the x coordinate of the vertex and my x coordinate is 0, then that means that the H is also 0. So I'm going to calculate f of negative 5, f of 0, and f of 8. Now, before we proceed, we need to check and see, is that H value, is it inside the closed interval? So in other words, does this H value, which is 0, is that between negative 5 and 8? And in this case, it is. 0 is in between negative 5 and 8. So therefore, we have to consider it. If it wasn't 0, if it was something like, I don't know, 20, 20 doesn't fall between negative 5 and 8, so we wouldn't have to consider it. But in this case, we do have to consider it because 0 is in between negative 5 and 8. So what we're going to do at this point is we are going to substitute these values into the parent function. So we're going to have to calculate the parent function or the given function 3 times. So I substitute in negative 5 for x, then I substitute in 0 for x, and then I substitute in 8 for x. Well, the absolute value of -5 is 5, the absolute value of 0 is 0, and the absolute value of 8 is 8. So after evaluating these three values in the given function, I come up with 5, 0, and 8. Now remember, your minimum is the smallest answer or the smallest y value, and your maximum is the biggest answer or the biggest y value. But we simply just don't want you to say, this is the min, this is the max. There's a proper way to format your answers, and you're going to want to start formatting your answers this way, because if you don't provide your answer in this format, you will lose half credit of the problem. And that's because the format is quintessential to expressing the maximum and minimum. So I look here and I say, well, my smallest y value, or my smallest answer, is right here at 0. Okay, but how did I get 0? Well, I evaluated f of 0. So this is the way I write my minimum equation, or my minimum answer. I'm going to say that f of 0 equals 0, because when the x is 0 and I evaluated the function, I got 0, which produced my minimum quantity. Okay, let's talk about the maximum. The maximum is the biggest y, or the biggest answer. So I see 8. But again, I can't just say, hey, 8's the maximum. I can't do that. I have to write it in the proper format. Well, f of 8 equaled 8. So I'm going to say f evaluated at 8 equals 8, and that's my maximum. Now let's focus on transforming the absolute value function. Everything we're going to talk about on this slide is related to the form of the equation that allows us to transform the absolute value function. The first thing we want to talk about is defining the vertex. Well, the vertex is h, k. So if you're given an equation in this form, obviously a, b, h, and k would be numerical values. To determine the vertex of your absolute value function, it is simply h, k. Now, one thing we're going to talk about here in a little bit that is very, very, very important is that inside the function, inside those absolute value bars, okay, it has to only be inside the absolute value bars, it's opposite day. So you kind of got to think of stuff when you're manipulating values that are inside that absolute value function. You have to kind of think in terms of opposite day, because everything is opposite. So even though it says x minus h, your h is going to be positive in that case. Okay, so if you see an x plus h, that's really going to be a negative h value, because the proper form is x minus. Okay, so that's why your vertex is hk, and we'll do some more exploration with that in a minute. So here's a table of value that tells you what the numerical values of b, h, a, and k, and how they affect the graph, and also how do they affect the x and y coordinates on the graph. So the first value we're going to talk about is b value. So b is inside the function. So now when we talk about the absolute value of b, what that's really telling you is when we're looking at b, we do not consider the signs right away. We'll consider the sign a little bit later, but when you're looking at b, you just have to look at b. If it's negative, ignore that negative just for a second and just look at the number that b is, okay? So if your b value is between 0 and 1, that's going to be a horizontal stretch. That's going to be a horizontal stretch. So imagine if you're holding silly putty or gum or whatever in your hands, and you stretch it out all as far as you can go left to right. That's like what the B value if it's between 0 and 1. That's how it affects the graph. It's going to take your graph and it's going to stretch it left to right. Now, if your B value is bigger than 1, if it's bigger than 1, then think of like an accordion. You know how you take an accordion and you press it together? That's what a B value greater than 1 does. It takes the graph and it presses it together towards the vertex. Now, here is where we're going to talk about if your B is negative, okay? If your B value is negative, that means it's also going to reflect across the y-axis. Okay, so it's going to flip over that y-axis. So the first thing you want to do is you want to consider just the B itself. Ignore the signs. Does it have a horizontal stretch? Does it have a horizontal shrink? And then if B is negative, then that's when you want to say, well, it's going to be a reflection across Y. Okay, so let me just tell you, you can have a horizontal stretch or shrink and a reflection. So, or you could have just a reflection over Y, or you could just have a stretch or a shrink. Okay, but so you could have a horizontal stretch or shrink and a reflection. Totally permissible. Okay, what is the effect on the X and Y coordinates though? Well, if B is an integer, so if that's 2 times X minus H, we're going to divide, because remember, anything inside the absolute value bars, that's going to be opposite day. So even though it looks like it's 2 times, when we go to calculate those X values, we're really going to divide by a 2. Now, if B is a fraction, we're going to multiply by the reciprocal of that fraction, because remember, dividing by a fraction is the same as multiplying by the reciprocal. Okay, and these are only going to affect the X's. B and H only affect the X's. Okay, they don't mess with the Y's. They only mess with the X's. Now let's talk about H. H is positive if it's X minus H. If it's X minus H, then your H is really going to be positive, and that means you are going to move to the right H units. If H is negative, so if you get something like X plus H inside your parentheses, that means you're going to, that H is really negative, that means you're going to go to the left H units. Okay, so X minus H, we're going to go to the right. X plus H, we're going to go to the left. So if it's X minus H, even though it says minus opposite day, we're going to add. So if it's X minus H, we're going to add H to every X. If it's X plus H, remember opposite, so opposite of add is subtract. We're going to subtract H from every X. Okay? So again, remember that B and H are inside the function, so it's opposite day. Okay? Now let's talk about the A value. Okay? So the A value and the K value, actually, the A and the K are outside the absolute value bars. So since A and K are outside those absolute value bars, then that means we can take them at face value. So if you're outside those absolute value bars, we're going to take you at not H value, sorry. We're going to take you at face value, okay? So we don't have to do any of that opposite day stuff like we do with B and H. So, and when we talk about this absolute value notation, taking the absolute value of A, the absolute, value of A, if it's this, really, what that really is telling us is that's telling us just look at the number that A is. Don't worry about its sign yet. We'll deal with its sign later. But right now, just look at what that value is, okay? So if that A value is between 0 and 1, it's a vertical shrink. It's a vertical shrink. So think about like our accordion, but this time our accordion is vertical, and we squeeze it towards the center. That's a vertical shrink. Now, if that A value is bigger than 1, then again, think of the silly putty. We're going to be stretching it. So we're taking that silly putty and we're stretching it up and down. That's what a vertical stretch does. Now we're going to focus on the sign. If your A is less than 0, meaning it's negative, then This time it's going to reflect over the x-axis. So if A is negative, it's going to reflect your graph over the x-axis. Okay, how does that really affect the coordinate points though? Well, if B and H affect the x's, then A and K, because they're on the outside, they're going to affect the y's. So whatever A is, you're going to multiply the y by that A value. Because remember, A and K, we take at face value. So you're going to take whatever your y value is, and you're going to multiply it by A. Okay, let's talk about K now. So K is outside the absolute value bars. So we are going to know that that's going to affect the y values. Okay, so it's outside the absolute value bars, so we know it's only going to affect the y, and it's taken at face value. Okay, so if K is positive, if it's a plus K, you're going to go up K units. Your function's literally going to move up K units. If K is negative, then that means like a minus K. That means you're going to take your function and you're going to move it down K units. Now, how does that affect the coordinate points? Well, remember, A and K, they only affect the y's. So if it's plus K, you're going to add that to every y. If it's minus K, you're going to subtract that from every y. Okay? So, and again, you're probably, this is all in theory, this is all relative. It's going to make more sense when we jump in here in just a second and do an example. So remember, this is super duper duper important. PEMDAS says that you multiply before you add or subtract. So since I have to multiply before I add or subtract, that means I'm going to apply B before H. Okay, I'm going to do the B before H. In terms of the y's, I'm going to apply the A before I apply the K. So PEMDAS says we do multiplication or division first to that value, and then we add or subtract. Now let's talk about how this transformation function affects our domain and range. Well, it doesn't matter if we move this dude up, down, left, right, stretch him, shrink him, reflect him. It doesn't matter. His domain is always going to be negative infinity to infinity. But the range changes. So our range is K to infinity if A is positive. So think about it this way. If A is positive, that means, just like a parabola, the absolute value is going to open up. So our vertex we know is HK. So if this vertex right here is at K, then that means my range is going to be K to infinity, because it's going to go from K all the way up. But what if A is negative? If A is negative, that means that it's going to be negative infinity to K. So again, if A is negative, that's going to make that dude, he's going to open upside down. And this HK is still my vertex. Okay, so if HK is still my vertex, in this case, K is as high as it goes. So your range is going to be from negative infinity all the way to K, and K always gets the bracket because that's as high as we can go. All right, so now that I've given you all this, mathematical mumbo jumbo, let's see how it affects a real problem. All right, let's see how this applies to a real life function. Now, so I'm given f of x equals -3 times the absolute value of x minus 2 plus 9. They want us to describe the transformation from the parent. They want us to give the domain and range and give the vertex. Now, before I do any of that, I want to mark up my function and to help me realize as I'm learning this, what represents what value. So this -3, that's outside the absolute value bars and right next to it. So I know that that -3, that's going to represent my A value. Now, looking at the b, well, the b is really the number in front of the x. So b is 1. So if b is 1, yes, he exists, but does he affect the function? Not really. So if b is 1, we don't have to really state that. We only really have to worry about the b if he's anything other than 1. So we're going to be like, okay, cool, we have a b value, it's 1, it doesn't matter. Okay, so x minus 2, that is going to be my h value. Because remember, it's minus x minus h. So that means h is 2. And then the plus 9. Well, the plus 9 is outside of the function, and it's being added or subtracted. So that way, since it's plus 9, or anything else that's being added or subtracted to the absolute value, that's going to be our k value. Okay, so we know h, that's h because it's inside the absolute value, and we know that the other one is k because he's outside the absolute value. So let's talk about our transformations. So we know at this point that a is -3. So we go to our chart, and for the first thing, we have to just look at the number itself. We're just like not even gonna go, oh, I don't even see that negative right now. We're just gonna be focusing on the 3, just the 3. So since that number is bigger than 1, according to my chart, if a is bigger than 1, then that means it's going to be a vertical stretch. It's going to be a vertical stretch by a factor of 3. So when we're describing this transformation, I'm going to be honest with you. If you say vertical stretch by 3, we're going to be totally cool with that. You can always say by a factor of 3, but you don't have to. You can just say vertical stretch by 3, and we're going to know what you're talking about. Now, it's important that you say vertical and by how much, okay? Because if you just say stretch, we're going to be like, no. Okay, we're going to know what kind of stretch is it. Well, is it vertical or is it horizontal? It's vertical. Well, by how much? 3. Okay, so it's crucial that you get vertical, stretch, and 3 in there, okay? Now let's focus on the fact that it is negative. Since a is negative, that means we are going to reflect over the x-axis. So yes, it is important that you say over the x-axis, because if you just say reflection, we're going to be like, okay, which way? So you have to say reflection over the x-axis. Also, because a is negative, that means that our absolute value is going to open down versus up. All right, so we have a b, it's 1, so we can just kind of like, okay, whatever, we're not going to mention him. But I do have an h value, and my h value is 2. And you're like, but remember, inside the absolute value function, it's opposite day. So if it says x minus 2, that really means your h is positive. If it says x plus 2, that really means your h is negative. So since it's x minus 2, that means it's going to be a positive 2. And if you refer to your chart, what does that do to your graph? Well, if it's x minus h, that means we go right h units. So we're going to go right 2 units. Now let's talk about the k value. Okay, so the k value is outside the absolute value, so we take it at face value. So that means k is 9. Now how does that affect our graph? So I go and I look, okay, k's, that means my graph is going to move up 9. Now let's talk about domain and range. Domain and range. So my domain is -infinity to infinity. And since it opens down, a is negative, that means that my range is going to be -infinity to this value right here. Okay, well, what's that value? That's the vertex. That's hk. So what is k? Well, k is 9. So since it opens upside down and my k is 9, our range is going to be -infinity to 9. And 9 gets a bracket. Let's talk about the vertex. Well, we kind of just touched upon that a minute ago. Your vertex is HK. So your vertex is 2, 9. And that's it. Now let's talk about graphing. So remember when I told you want to remember these parent functions because it's a lot quicker than having to recreate the parent function table. So we're going to start with our parent function table, negative 2 to 2, 2, 1, 0, 1, 2. Now we're going to manipulate our x's and y values to do our graphing. So we are going to manipulate the parent function table. And you'll notice I have kind of a bigger space at the bottom. That's where I write what operation I'm doing. So in terms of the x, only b and h affect the x values. Only b and h. Okay? Well, b's 1, so let me just kind of ignore him. But inside, it says x minus 2. Remember, inside, it's opposite day. It's opposite day. So if it says x minus 2, what it's really telling us to do is we are going to add 2 to our x's. So negative 2 plus 2 is 0. Negative 1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. Okay, so we've got our x values. Now, in terms of the y values, those are affected by a and k. But remember, a is a multiplying factor, k is an addition or subtraction factor. So everything outside those absolute value bars affects the k. I apologize, affects the y. So a and k are going to affect the y. So that means I'm going to multiply by negative 3 and I'm going to add 9. But oh goodness, what do I do first? Think back to PEMDAS. PEMDAS says we multiply before we add or subtract. So that means I'm going to apply the negative 3 and then add or subtract the k. In this case, I'm going to multiply by negative 3 and then I'm going to add 9. So negative 3 times 2 is negative 6. Negative 6 plus 9 is positive 3. Now I'm going to tackle the 1. Negative 3 times 1, negative 3. Negative 3 plus 9, 6. Let's try 0 now. Negative 3 times 0 is 0. 0 plus 9 is 9. 1 times negative 3, negative 3. Negative 3 plus 9, 6. 2 times negative 3, negative 6 plus 9 is 3. Now I am going to graph the new table I just created. So there's 2, 9, and then there's the remaining points. Now we just do the fancy game of connect the dots, and there's my function. So now, using that same function and the same graph, let's calculate the max and min over the interval 0 to 3. Now we know that 0 is our left, we know that 3 is our right, so we're going to have to do, because it's the absolute value, we're going to have to do f of L, f of h, and f of r. Well, if you remember from this function, h is 2, so that means I'm going to calculate f of 0, f of 2, and f of 3. But before we go on, is 2 in between 0 and 3? Yeah, it is. So we have to calculate it. If it wasn't, forget it, cross it out. We don't have to do it. But this time it is in between 0 and 3, so we have to consider it. So I'm going to plug 0 in for x, then I'm going to plug 2 in for x, then I'm going to plug 3 in for x. So let's try 0 first. 0 minus 2 is negative 2. So that gives me negative 3 times the absolute value of negative 2 plus 9. Well, the absolute value of negative 2 is positive 2. So negative 3 times 2 is negative 6. Negative 6 plus 9 is 3. Okay, 1 down, 2 more to go. Let's try 2. Well, 2 minus 2 is 0, so that becomes the absolute value of 0. Absolute value of 0 is 0, so negative 3 times 0 is 0. 0 plus 9 is 9, which it should be because that's our k value. Okay, let's try positive 3. 3 minus 2 is 1. The absolute value of 1 is 1. Negative 3 times 1 is negative 3. Negative 3 plus 9 is 6. So I want the minimum. So my smallest output is 3. So my smallest output is 3. So that means my minimum is going to be f of 0 equals 3. Remember, we gotta write it in the pretty notation. So f of 0 equals 3 is our minimum. Now let's talk about our biggest y value. Our biggest y value, our biggest output, our biggest answer is 9. But we can't just say, woo, 9's the max. We have to say f of 2 equals 9 is the max. Now, these two questions are going to make us think over what interval of the domain is the function increasing. So it wants to know over what part of the x's are the y's continuously getting bigger. Okay, so increasing, meaning it's going to be going up, meaning positive slope. So my y's are increasing from here to here. So that's going to be negative infinity to 2. And remember, it's asking for the interval of the domain. So over what set of x values are your y's getting bigger? So they are getting bigger from negative infinity to positive 2. Now let's look at over what interval of the domain is the function decreasing. So on what part of the x's are the y's getting smaller? So I look right here and I'm like, well, they start getting smaller here. So they start getting smaller at 2, and then they just keep getting smaller as we go to infinity on the x's. So basically, when they ask you that, you're really just, when they say over what interval is it increasing, over what interval is it decreasing. Now, if it was A is positive, that'd kind of be a little flipped, but you just kind of have to look at your graph. So you're breaking that negative infinity into like a negative infinity to the h, and then an h to the infinity. So you're kind of just saying this part's increasing, this part's decreasing. Okay, let's now find the x-intercept and the y-intercept. Yes, this is the same function. Yes, this is the same graph. Okay, y'all are going to be so tired of this one by the time we're done. But we're just finding everything we can possibly find about this. So we're going to find the x-intercept, and then we're going to find the y-intercept. So the x-intercept is where y equals 0. The y-intercept is where x equals 0. So let's do x-intercept first. I'm going to replace f of x for 0. And then guys, this is just what we did back on 3.2. We're just going to solve this dude. So I'm going to subtract 9 from both sides. And that gets me negative 9 is equal to negative 3 times the absolute value of x minus 2. Well, we can't distribute over those absolute value bars because we don't want to be crispy critters. So we're going to divide by negative 3. That's going to give me positive 3 is equal to x minus 2. Okay, so now this is where, well, that inside could be a positive 3 or that inside could be a negative 3. So I break it apart and I add 2 to both sides. So that gets me x is 5 and x is negative 1. Always, always, always plug it back in and make sure it works. So 5 minus 2 is 3. Absolute value of 3 is 3. 3 times negative 3 is negative 9 plus 9 is 0. It works. 1 minus -1 minus 2 is -3. Absolute value of -3 is 3. 3 times -3 is -9 plus 9. It works. Okay, but so they both work, but you can't just leave it written like that. And this is where you will lose points for formatting. Okay, you have to write your x-intercept as coordinate points. So that's going to be -1, 0 and 5, 0. Remember, you have to write them as coordinate points or else you are going to lose credit. Now the y-intercept is where we sub in 0 for x. So this is pretty straightforward. 0 minus 2 is -2. Absolute value of -2 is 2. -3 times 2 is -6. -6 plus 9 is 3. So our y-intercept is 0, 3. And we can also confirm that by looking at the graph. Now, let's answer these questions. What is the slope of the line on the graph? So you can really pick any 2 points. So on the left, I'm going to go up 1, 2, 3 over 1. So on the left, it's up 3 over 1. On the right, it's down 1, 2, 3 over 1. 3 over 1 and -3 over 1. What does that resemble? The A value. Keep that in mind. We're going to show you how to use the A value and B value if it exists to help you graph. Okay. Is the function symmetrical? Is there an axis of symmetry? Can I fold this fraction in half along a vertical line? Yeah, if you look right here, this line right here, we could fold it in half through the vertex. So your vertex is going to be where you fold it along. So the axis of symmetry, that equation, not coordinate, but that equation is always going to be x equals h. So if they ask you for the axis of symmetry, it's always going to be x equals h. Well, h is 2. So that means my axis of symmetry is x equals 2. Now let's look at a graph that actually has a B value. So before you do anything, before you talk about H, K, A, and B, if there is a number in front of X, you've got to factor that inside. You've got to pull that 2 out, kind of like a GCF, but not really. Okay, so because if you think about it, if you remember the inside of the absolute value bars, it's B times X minus H. So it's B times X minus H. So you've got to, it's still inside the absolute value bars, but you've got to factor it out so it's a standalone factor. Okay, so that's the first thing I'm going to do. I'm going to factor a 2 out. So now that it's in the proper transformation form, 2 times a quantity, I can now determine A, B, H, and K. So my A is -3, my B is 2, my H is 2, because remember it's X minus, so my H is +2, and my K is 6. The absolute value is going to open, A is negative. So if A is negative, that means he's going to open down. If A was positive, he would have opened up. My vertex is HK, so my vertex is 2, 6. And then to figure out the slope of each side, okay, so you can tell I put H and K there. To figure out the slope of each side, I'm simply going to do plus or minus the A times the B. Plus or minus the A times the B. Because remember, you're going to have a positive slope and a negative slope, or a negative slope and then a positive slope as we approach the vertex. So all you have to do is plus or minus a times b, which a is 3, b is 2. Okay, now I'm going to show you two ways to graph this. Okay, the first way we're going to apply the parent function method. So there's my parent function. So how am I going to go from old x's to new x's? Well, I've got a b value, but I've also got an h value. So b and h, they're inside the absolute value bars, so that means it's opposite day, but that also means it affects only the x's. So, even though it says multiply by 2, opposite day says divide. So even though it says multiply, I'm going to think opposite day. So that means I'm going to divide by 2. And instead of minusing 2, I'm really going to add 2. Okay? But what do I do first? Do I multiply and then add, or add then multiply? PEMDAS says you multiply first. So multiply, divide, that's really what it says. So we are going to divide by 2, then we're going to add 2. And guys, if this helps you, always do the B and then the H, because B comes before H in the alphabet. So that's another key point to help you remember. So you are going to divide each x by 2 because it says 2 times. So really, we're going to divide by 2. And then we're going to add 2 because it says minus. I know you're like, what? Okay, so 2 times. What's opposite of 2 times? We're going to divide by 2. And then it says x minus 2. But, opposite day, we're going to add 2. So we're going to divide by 2 and then add 2. So negative 2 divided by 2 is negative 1. Negative 1 plus 2 is positive 1. Negative 1 divided by 2, because we're graphing, we can use a pretty decimal. So negative 1 divided by 2 is negative 0.5. Negative 0.5 plus 2 is 1.5. 0 divided by 2 is 0, plus 2 is 2. 1 divided by 2 is 0.5. 0.5 plus 2 is 2.5. 2 divided by 2 is 1. 1 plus 2 is 3. Now, let's talk about the y's. Okay, well, the a and the k, they affect the y's. So I have a negative 3 and then a plus 6. So that's going to be a negative 3 times and a plus 6, because we take a and k at face value. So, do I multiply and then add, or add then multiply? Remember PEMDAS. PEMDAS says we're going to multiply by negative 3 and then we're going to add 6. So, negative 3 times 2, negative 6, plus 6, 0. 1 times negative 3, negative 3, plus 6, 3. 0 times negative 3, 0, plus 6, 6. 1 times negative 3 is negative 3. Negative 3 plus 6 is 3. 2 times negative 3, negative 6, plus 6, 0. Okay, so I'm going to plot those points. And then we connect the dots. Now, I'm going to show you a unique way to help us graph. Now, this will work regardless of if you have a B or not. Okay, so this will work if you just have an A. It'll work if you have a B. It'll work if you have an A times B. So just remember this formula right up here. The slope is plus or minus A times B. So A times B in this case was 3 times 2, which is 6, so plus or minus 6. The first thing you do is you plot the vertex. So I know the vertex was 2, 6. And then I also know it's going to open down. So I'm going to go down 6 over 1. And then I'm going to go down 6 again, go back to the vertex, go over 1. Now, as that's done right there, that's only 3 points. Okay, remember my graphs have to have 5. So I go back to these x-intercepts, and then I go down 6 again. So 1, 2, 3, 4, 5, 6 over 1. And then I also go back to the x-intercept at 3. I go down 6 over 1. So you have to have 5 graphs. I mean, not 5 graphs, I'm sorry, 5 points. So if you do it with the table, you're going to get those points in between the vertex and the x-intercepts. If you do it with the slope, you're going to have the vertex, these two here in the middle, that just this time they happen to be the x-intercepts, and then you have the other 2 points below. So now this little trick of applying the slopes to each side, that only works on the absolute value. It's not going to work for any other function. It only works for the absolute value. So if you use the little slope trick, I want to see you state your vertex and the slope before you graph. So you would go, oh, my vertex is 2, 6. I know it's going to open down. Here's my slope formula. So I go to the vertex. I go down 6 over 1, down 6 over 1. Go back to the vertex, go down 6 over 1, go down 6 over 1, and connect the dots. Okay? That's all you have to show me if you use your slope trick on each side. But if you're like, dude, I want one way that works every time for every parent function, then that would be the 2 tables and graph the 2 tables. But on absolute value, it doesn't matter to us. We don't care. You can do the tables or you can do the slope trick. Either way. Okay, let's look at another function. F of x equals 2 times the absolute value of 1/2 x minus 1 minus 3. Now, before I can determine what a, b, h, and k are, I have to factor that b value out. Because remember, in the transformational form, it's b parentheses x minus h. So we have to factor that b out. Now, you're probably looking at this going, wait, how'd you go from 1 to 2? Well, remember, anytime you factor something from a term, you're really dividing it by what you're factoring by. So I'm really taking 1 and I'm dividing it by 1/2. But remember, dividing fractions, don't ask why, flip the second and multiply. So we really get 1 times 2, which is 2. Another way to think about it is 1/2 times what would produce 1? Well, 1/2 of 2 is 1. All right, so that's how we got that 2. Now let's focus on our a, b, h, and k. So a is 2, b is 1/2, h is 2, k is -3. So how do we go from the old x's to the new x's? Well, that concerns b and h. But remember, b and h are opposite days. So instead of multiplying by 1/2, I'm really going to divide by 1/2, which is really multiplication by 2. And then instead of subtracting 2, I'm going to add 2. But do I add and then multiply or multiply then add? PEMDAS says I should multiply first. So I'm going to multiply by 2 and then add 2. So 2 times -2 is -4 plus 2, -2. 2 times -1 is -2 plus 2 is 0. 2 times 0 is 0 plus 2 is 2. 2 times 1 is 2 plus 2 is 4. 2 times 2 is 4 plus 2 is 6. Then we talk about the y's. Well, y's are affected by a and k. A and k are taken at face value. So according to PEMDAS, we're going to multiply by 2 and then subtract 3. So 2 times 2 is 4, minus 3 is 1. 2 times 1 is 2, minus 3, -1. 2 times 0 is 0, minus 3, -3. 2 times 1 is 2, minus 3, it's -1. 2 times 2 is 4, minus 3 is +1. So what I'm going to do is I am going to plot these 5 points, and then I'm going to connect the dots. Now, you're like, well, wait a minute. This is the parent function method. What if I wanted to do the slope method? Well, okay, here's what you'd show me. You'd say, first of all, the vertex, that's h and k, so that's 2, -3. So I'd go up here and I'd go, okay, 2, -3. There we are. I know that A is positive, so it's going to open up. And then I know that my slope, that's plus or minus A times B. Well, my A value is 2, my B value is 1/2, so that's really plus or minus 1. So I'm going to go up 1 over 1, and then I'm going to go up 1 over 1 again. Then I'm going to go back to the vertex. I'm going to go up 1 over 1, up 1 over 1. So in this case, I would have these 5 points, and then you connect the dots. So you can still do the slope method also. All right, so they want us to write the absolute value function that has the following transformations. Right 6, up 2, vertical stretch of 5, horizontal shrink of 3, and a reflection over the x-axis. Goodness gracious. So right 6, that tells me that h is positive 6. Up 2, that means k is positive 2. Vertical stretch of 5, that means that A is 5. Horizontal shrink of 3, that means B is 3. Reflection over X, that means A is negative. And then I just fill in A, B, H, and K into the equation. Now, some people ask, can I multiply 3 times x minus 6 and make it 3x minus 18? Well, you can, but that's an extra step. I mean, you can do it. It's totally mathematically appropriate. But if you want to stop there, you're done. Okay, what if they give me the graph and they ask me, what is the equation of the absolute value function? Well, the first thing I notice is that it opens down. So that's going to tell me that A is negative. Okay, that's going to tell me that A is negative. And then from here on out, we're just going to reverse engineer the slope method. So first thing I notice is that my vertex right here is at -1, 4. So that's my vertex, -1, 4. And then I'm just going to do the slope of each side. So I'm going to go down 1 over 1, 2, 3, or I could go down 1 over 1, 2, 3. Either way, your slope is going to be -1/3. Now I put H, K, and A into the equation. And you may be thinking, well, what about B? Well, here's the deal. Anytime we give you a graph and we tell you to write the equation, B is always going to be 1. We're never going to make you supply a B value other than 1 because it's too confusing and convoluted to determine, well, is that an A factor, is that a B factor? So when we ask you to write the equation, we're always going to let you assume B is 1. So I only have to plug in A, H, and K into the equation, and that's what I get. Now you're like, wait a minute, it went 1, it became +1. Well, that's because H was negative. So X minus a -1 is X plus 1. And that's all there is to it. All right, on this example, we're just going to have you identify some parts. So what we want you to do here is pause the video, and we want you to tell us, find the vertex, the HK, give the domain, the range, the y-intercept, the x-intercept, and the slope of each side. So pause, and then when you're ready to check your work, hit play, and we'll check. Okay, so I had to factor out the 2, and that gave me x plus 4, and then minus 4 on the outside. So my vertex was -4, -4. My domain is still -infinity to infinity. It's going to open up, so my range is k to infinity, so it's going to be -4 to infinity. I found my y-intercept. I found my x-intercepts. And then the slope of each line is a times b, so it's 2 and -2. Last example. A ride at an amusement park carries passengers along a vertical tower to give them a view of their surroundings. During the test run, a park employee records the height of the ride for 10 seconds. The function f of x equals absolute value of x minus 5 plus 4.8 models the height f of x of the ride in meters after x seconds. Graph the function and interpret the domain, the range, the intercepts, the symmetry, the maximum, and the minimum for the situation. So the vertex, you're probably going, well, where's the b? Well, in this case, the b is 1. So we can use the form a times x minus h plus k. So my vertex is 5, 4.8. The slope of each side, remember, is plus or minus a times b. Well, that's 1. So 1 and -1. For the y-intercept, we're going to plug in 0 for x. And I come up with 0, 9.8. For the x-intercept, I get 0 equals, because we plug in 0 for y, the absolute value of x minus 5 plus 4.8. But wait a minute. Absolute value cannot equal a negative. So there are no x-intercepts. So we graph. I graph the vertex, and then I go up 1, over 1, up 1, over 1 to come up with this graph. Now you're probably thinking, where are the arrows? Well, it doesn't go to an infinite height. It can only go to a certain height. So that's going to be equivalent to almost our y-intercept. So the tallest it's going to go after 10 seconds is 9.8. So you could get that by plugging in 0 for the x, because that's the y-intercept. And then at the end of the 10 seconds, you could plug 10 seconds into the equation, and you would also come up with 9.8. So 9.8 is as high as it's going to go. All right. Axis of symmetry, that goes straight through the vertex. Remember, that's x minus h. So that's x equals 5. The maximum height that's ever going to hit, which is what we just talked about, is 9.8 meters. Okay, so after 10 seconds or at 0 seconds, the highest it's going to go is 9.8. The minimum, well, the minimum is the k value, so it's 4.8. Now, the domain of this function is 0 to 10, because it's not the domain for the equation, it's the domain for the situation. Well, the ride was only 10 seconds, so from 0 to 10, that's the only domain I have data for. So 0 to 10, because it's a precise moment in time. And then the range, well, the lowest it goes is 4.8. The highest it goes is 9.8. So from 4.8 to 9.8 is your range. And again, remember, this is the domain and range for the situation, not for the equation. It's just over this brief snapshot in time. Okay, so this is the end of the lesson. You will now go complete worksheet 3.3, submit that to your teacher through Canvas, and have a great day. Bye, everyone.